Mars is a fascinating planet. It's the fourth planet from the Sun in our solar system and is often called the Red Planet due to its reddish appearance, which comes from iron oxide rust on its surface. Mars has the largest volcano in the solar system, all investments, and a canyon system, Valles Marineris, that dwarfs the Grand Canyon. Scientists are very interested in Mars because it has seasons, polar ice caps, and evidence of past water flows, which makes it a prime candidate for studying the potential for past or present life. There are several missions exploring Mars, like NASA's rovers Curiosity and Perseverance, that are searching for signs of ancient life and studying its geology. Is there something specific about Mars you're curious about? The surface of Mars is diverse and intriguing. Color and composition. Mars is known for its reddish appearance, which is due to iron oxide rust on its surface. The surface is composed of volcanic basalt and has varying shades of red, orange, brown, and yellow. Topography. Mars hosts the largest volcano in the solar system, all investments, which stands about 20 kilometers 13.6 miles high and is around 600 kilometers 373 miles in diameter. It has a very gentle slope because of the low gravity and the lack of tectonic plate movement. Canyons Valles Marineris is an extensive canyon system that stretches over 0 kilometers 2,500 miles long, 200 kilometers 125 miles wide, and up to 7 kilometers 3 miles deep. It's one of the most dramatic landscapes in the solar system. How humans will get oxygen on Mars. Humans would need to use innovative technologies to produce oxygen on Mars, as the planet's atmosphere is 95% carbon dioxide too, and has very little oxygen. Mars, by contrast, lacks these essential conditions, which is why significant technological advancements are needed to support human life. Their humans live on Earth, which provides the ideal conditions for life, such as an atmosphere rich in oxygen, liquid water, and a moderate climate. Earth's atmosphere is about 21% oxygen, which supports respiration for humans and other life forms. Additionally, the planet's magnetic field and ozone layer protect us from harmful solar radiation, making it a habitable environment. Oxygen on Mars is scarce. Mars' atmosphere is composed of about 95% carbon dioxide, and only about 0.13% oxygen, compared to Earth's atmosphere, which contains 21% oxygen. This means humans cannot breathe Mars air directly and would need to create oxygen through technology or bring it from Earth. One promising method for generating oxygen on Mars is MOXIE, Mars Oxygen in Situ Resource Utilization Experiment, a technology developed by NASA. MOXIE extracts oxygen from the carbon dioxide in the Martian atmosphere using a process called electrolysis, which splits into oxygen and carbon monoxide. Other potential ways to generate oxygen on Mars include greenhouses with plants. Greenhouses with plants on Mars could be a practical way to produce oxygen through photosynthesis. Plants naturally taking carbon dioxide and using sunlight, convert it into oxygen, O2, and glucose. Here's how greenhouses could work on Mars. Controlled environments. Since Mars' atmosphere is thin and cold, with little oxygen, greenhouses would need to be sealed, climate-controlled structures. They would simulate Earth-like conditions, temperature, pressure, and humidity to allow plants to grow. Artificial lighting or sunlight. While Mars receives sunlight, it's weaker than on Earth. Greenhouses could use transparent materials to maximize sunlight, or use artificial lights powered by solar energy or nuclear sources to support plant growth. From the Martian atmosphere. Mars' atmosphere is rich in carbon dioxide, 95%, which plants need for photosynthesis. A greenhouse could tap into the local atmosphere to supply this too, helping the plants produce oxygen. Water supply. Water is essential for plants. Mars has ice in its polar regions and possibly underground. By extracting this water and using it in hydroponic or traditional soil-based systems, plants could thrive. Oxygen generation. As plants photosynthesize, they would release oxygen, which could be collected and stored for astronauts to breathe. Benefits. Sustainable oxygen production over time. Greenhouses could provide a continuous supply of oxygen, reducing dependence on imported oxygen from Earth. Food supply. In addition to oxygen, greenhouses could grow food for astronauts, making them a key part of long-term habitation plans on Mars. Electrolysis of water. The electrolysis of water is a process where water O is split into oxygen O and hydrogen H using electricity. This method could be crucial for generating oxygen on Mars. especially if ice or water sources are found in mind. How electrolysis of water works. Water source on Mars. Ice has been found at the poles and potentially underground. By melting this ice, water could be collected for electrolysis. Electrolysis process. Water molecules are composed of two hydrogen atoms and one oxygen atom, Ho. An electrical current is passed through the water using electrodes. The water molecules split into hydrogen gas, H, at the cathode and oxygen gas, O, at the anode. Electricity, solar panels, nuclear power, or other energy sources would be needed to supply the electricity for the process. Why it's important for Mars? Oxygen production. The oxygen produced would be essential for astronauts to breathe and could be stored for use in habitats. Rocket fuel. The hydrogen produced, when combined with oxygen, could be used as rocket fuel for returning to Earth or for further exploration missions. Potential challenges. Energy demand. Electrolysis requires significant energy, which means reliable power sources are necessary on Mars. Water availability. While ice exists on Mars, finding and extracting it efficiently could be challenging. Systems to mine and purify water would need to be developed. The electrolysis of water offers a sustainable way to produce both oxygen and fuel, making it a critical technology for long-term human missions on Mars. Artificial lighting or sunlight. On Mars, both artificial lighting and sunlight could be used to support plant growth in greenhouses, each with distinct advantages and challenges. Sunlight on Mars. Weaker sunlight. Mars is farther from the sun than Earth, so it receives only about 43% of the sunlight Earth gets. This could still be enough for plants to grow, but greenhouses would need to maximize the available light. Transparent greenhouses. These would be built with transparent or semi-transparent materials that allow sunlight to pass through. Similar to greenhouses on Earth, special coatings could filter harmful radiation while letting in the necessary wavelengths for photosynthesis. Artificial lighting. Artificial lighting, such as LED lights, can provide consistent and controlled light for plants, regardless of dust storms, day-to-night cycles, or other environmental factors. LED lights can be tailored to emit the specific wavelengths plants need for photosynthesis, especially in the red and blue light spectrum, which are most effective for plant growth. Solar panels or nuclear energy could power artificial lighting systems on Mars. Running artificial lights requires significant energy, so large-scale solar or nuclear power systems would be necessary. The lighting equipment must be durable enough to operate in Mars' extreme conditions